Hello, my fabulous chemistry students. Notes number 5. Today we are going to look at precipitates. Okay, we will be able to predict if a precipitate will form or if it will not when I've mixed two solutions together. We need to define precipitates, and then we need to use table F in our periodic table, or I'm sorry, in our reference tables, and it is probably the hardest of all of the reference tables to read accurately. And you're going to find that in this particular section is where we used the bulk of everything we've learned for the year. So this is going to take me a little while to get through. So sit back, relax, and get comfortable. Okay, we've heard of precipitate before in terms of weather. That's not what it means in chemistry really at all, but a little bit. Okay, a precipitate in chemistry means that a solid, insoluble product is formed when the reaction happens of mixing two solutions. This insoluble solid will fall out of solution to the bottom and make it look like a saturated solution. But because I mixed two solutions and there was a chemical reaction, that isn't necessarily the case. Okay. It also gives us signals that the end or the completion of the precipitation reaction has happened. Okay. So solubility table F. This is a grand list of what is and what isn't soluble. We can use it to predict whether or not a precipitate will form when we have a reaction. So a precipitate is the insoluble product that falls to the bottom. The nice thing about a precipitate and what we think of weather as precipitate, right? Like snow is technically a precipitate, right? Any kind of rain or anything falling out of the sky is a precipitate. So this will actually happen within the solution and settle to the bottom. So in that regards, it's kind of like the weather that we already know, but it's a little bit different in chemistry because it's going to be not snow, it's going to be a chemical, okay? A precipitate will form or a visible reaction will occur if one or both of the products listed is insoluble. Okay, we're going to do a very intense lab on this. And this is table F, so I'm going to take a minute and talk about it so you understand how to read it. Okay, so first things first, we have to break it up left side, right side. So let's deal with just the left side right now. I'll highlight it in green. I'm going to stay right over here the whole time. I'm not going to the other side. And the reason why I want to start on this side is it is ions are soluble, okay? And this piece here, the exceptions for soluble is insoluble. So this is how we read it. All group 1 ions they're under the soluble line. So everything over here is soluble. This box, soluble. Okay, all group 1 ions, lithium, sodium, etc., are soluble. Anything attached with an ammonium ion is soluble. Anything that has a nitrate is soluble. Okay, we're getting the hang of this. Let me jump down to the bottom. All halides, chlorine, bromine, and iodine, are soluble. But here is the exception. There is an exception to this. If the chlorine is hooked to a silver, a lead, or a mercury, it will then become insoluble. It's under the insoluble line. Okay? This is how we read it. Gets a little confusing, I understand, but with some practice, we're going to be good at this. Okay? Now, this other side, let me grab a different color. This other side reads opposite. Now, it only reads opposite because these things all start off as insoluble. So all carbonates are insoluble. The exception to insoluble would, of course, be soluble. So a carbonate will be soluble if and only if it's with a group 1 ion or ammonium. And I already learned that all group 1 ions are soluble and ammonium is soluble. So see how it kind of makes sense. All right, and this is how we read it. Hydroxide, OH, all hydroxides are insoluble except when they're with a group 1 ion, calcium, barium, beryllium, or ammonium. Okay, so this is how we read it. So I'm going to erase this here and give you just another little way to look at it. This big me table F? Well, I don't get too nervous or worried when somebody tells me, oh, this is the hardest table, because if you think about it, guys, there's a bunch of tables on the reference tables. One of them has to be the hardest. It's just what we call mathematics, law of probability. So I'm going to draw a line here, and I'm going to draw a line here. Okay, I'm going to scroll down a little bit. Not sure why this, oh, I see why the columns there. I'm going to extend the page. What I'm going to do is I'm going to draw this. Okay, so both middle columns are insoluble. Can't spell, but you heard me say it. Insoluble. So now this side, column 1 is, these are all soluble. And this column here is soluble. So if I'm here or I'm here, I'm soluble. If I'm in either of the two middle columns, I funnel down into insoluble. Okay? That's how we read this thing. But of course, there's more to it. So, how to use table F. I need you to read all through this and then kind of take what it says and what I say into something that works for you. Okay? Using table F, determine whether the following are soluble or insoluble. KNO3. So my personal opinion is the easiest way to do it is KNO3 is K plus with NO3 minus. Now we know this from bonding that I have this polyatomic ion nitrate with this sodium ion metal. Okay? Okay, well, I would say always start with my negative species. So let's go back to table F and look up NO3. This is going to be the fastest and easiest way to do all this. NO3. Where on this big bad table do I see NO3? Uh-oh, why did I do that? There we go. Sorry. Technical difficulties for 1 second. NO3. Oh, look, I found NO3. NO3. All nitrates are soluble. Damn. That's simple. That's simple. So, KNO3, all nitrates are soluble. I think I said that right. I'm not good at spelling. Okay. CaCO3. Now, we all know that CO3 is going to be the negative carbonate. Okay, we've learned table E. We're going to get very good with table E. Let me fly back to this piece because you have it on the same, probably on the same page, but I do not. Where do I see carbonate? CO3. CO3. Oh, here he is. Carbonate. All carbonates are insoluble except with a group 1 metal or ammonium. So now I got to see, is the metal that it's attached with group 1 or ammonium? Let's go back. Ca. Is Ca in group 1? No, it's not. It is group 2. Is Ca ammonium? No, it is not. So it is going to be insoluble because it's not an exception to the solubility rules for carbonate. So doing that, I want to see you do these next two practices on your own and see if you can get them. Start with, in this case, sulfate, and in this case, hydroxide. And don't forget to thoroughly vet the exceptions. Okay? So, solubility. Let's define these things real quick. We've been talking about them. I would have liked to have, I guess, maybe just defined them first, but soluble means it will dissolve. Miscible. This is what we call two liquids. Two liquids, we don't say they dissolve. We say they're miscible or they mix. Okay? Oil and water are immiscible. Okay? Insoluble does not dissolve. Okay? Concentration. This is not, in chemistry, this is not how hard we think. Next notes is actually we get to determine this. This is the ratio of the amount of solute per amount of solvent, solute versus or divided by solvent. That's just some definitions of that stuff. Dilute solution has a relatively small amount of solute dissolved into a relatively large amount of solvent, it's going to be what we call a weak solution. Okay? Verb, to weaken the concentration of a solution. So dilute equals little bit of solute over a lot of bit of solvent. See how the the words are bigger and smaller there? So there's just not a lot of stuff in there. Okay? Concentrated is a large amount of solute dissolved into a relatively small amount of liquid or solvent. Hence, it's a strong solution. There's a lot of stuff in that given amount of liquid. So let's use a Kool-Aid analogy here. If I take one packet of Kool-Aid and I put it into 1 liter of water, I could say I have a dilute solution compared to if I take 5 packets of Kool-Aid and put that into the same 1 liter of same amount, 1 liter of water. The one with 5 packets of Kool-Aid would be more concentrated. There'd be more solute per solvent than the other species. Okay. So most versus least concentrated using table F. Concentration is directly related to the solute dissolved. Okay, so most concentrated is soluble, least concentrated just means insoluble. And that's just for these questions when they say, which of these is more soluble? Basically, they're just trying to say which one will dissolve because the other ones will not. And that's just how they word that. Okay, so that's just kind of a little bit of a catch with how they particularly ask questions. All right, so now here's where we get to have some fun. Okay, because this is going to require everything that we've done to this point in chemistry basically to be able to do. So it says silver nitrate and sodium chromate solutions are mixed together. Will a precipitate form? If so, what is the name of the precipitate? And this is basically what your lab is going to be for this particular precipitate lab. And yes, you're going to have to do all of this stuff. It's going to be tough work and you're going to be a better chemist for it. So it says write the chemical or word equation for the double replacement reaction. So you're going to be given this and this. And what you need to be able to do is remember that during a double replacement reaction, the positive ion is going to hook up with the negative ion of the other species. And conversely, the positive ion of this species will hook up with the negative of that. Okay? Now, I don't bring my subscripts over. All I bring over is my charges. Remember this. And then I crisscross my charges down to form new subscripts. Once I form new subscripts, then I can balance. Okay? But once I form new subscripts, then I can at least see what I have. Okay? So this you will have to determine right here, my two products. Then I'm going to take those products and go to table F. And I'm going to look at chromate first. Okay? And on table F, let me grab my reference tables. I know this is running long, but this is the one time we get to go through these kind of notes in detail, and I want to make sure that we're all clear on how we use this table F on page 2. So I'm going to start with my chromate, and oh, look, it says chromates on the, it would be in the third column. It says all chromates are insoluble. The exception is with group 1 ions, calcium, magnesium, or ammonia. I am with silver, which is neither of those, so it's not an exception, so it precipitates. So now we need to try some. Okay. And let me help you with a couple, 2 or 3 of these. I see one. The first one's done. So we need to be able to do 2, 3, and 4. How about I do 1 and you do 2 and we'll be good to go. Looks like number 4 is the hardest, so I'm going to start with that. Okay, I'm going to take the positive species and the negative species and put them together. So that is LiNO3. And then I'm going to take the positive species and the negative species and put them together. That is NH4CrO4. And now I have to do a little bit of extra work actually because I got to make sure this is done right. So my reference tables tell me, the periodic table tells me that lithium is a +1 ion. And I go to table E and I see that NO3 nitrate is a -1 ion. When I crisscross my ones down, I put a 1 here and a 1 here. And because they're ones, I don't have to write them, right? So that's going to turn into LiNO3. And if you want to put a parentheses around that, you can. But notice the subscript behind it is blank. It's a 1. I don't have to write it. Okay? Now, next piece. NH4 is ammonium ion. Look it up in table E. It is a +1. And chromate, CrO4, is a -2. So I crisscross the 2 down here, I crisscross the 1 down here, and rewrite it. So what I'm going to do is erase so I can rewrite. Because the NH4 gets the 2, I'm going to put it in parentheses and put the 2 there. And then the chromate, CrO4, is going to have a 1, so I can just leave it like this, or I can put parentheses around it and leave the 1 off, whichever one works for you. Okay, but that's how we crisscross. And now we have stable compounds. Now on to table F, which luckily is on the same page. Let me start with this nitrate species first. I see in column 1, all nitrates are soluble, so I'll give that an S. I'm going to start now with chromate, which is the negative species on this ammonium chromate. And I see that all chromates are insoluble, except when they're with ammonium. When they are with ammonium, they are soluble. So both of these are soluble, hence no precipitate. Okay, there we go. I just walked you through how to do one of these. You need to go through and do these other two if you want full credit. Let me give you a little hint. The silver is going to go with the chlorine. The potassium is going to go with the nitrate. And I think you can do the same thing for number 3. Just please don't bring the subscripts along. Now, I brought this 4 along because that's part of what we call a polyatomic ion. Notice I did not bring the 2. I did also bring the 4, and I also did bring the 3, but you need to understand in table E, those are polyatomic ions, so they have to come together. That's just the rule of polyatomic ions. Okay, so now you can do a little bit more practice on page 10 and 12. You can take solutions prep number 3, and then you can take solutions quiz number 3, solubility rules. Okay, so we did a lot there. I'm sorry that this one went so long. Oh my goodness, 18 minutes. You'll have to forgive me. It is just the nature of the beast. It is the longest of all the videos. A bunch of them also were really short. So be well, good luck, study hard.